So this problem says solve by factoring. But before we do, we have to make sure that these equations that we're solving for are in standard form. And that's what we see here. That says ax squared plus bx plus c equals 0. So essentially what that means here is on the right side or left side, we have to have a 0. That's important and necessary. And another thing to notice here is that this says ax squared plus bx plus c. So I went from an x squared to an x to a number. So we call that putting it in descending powers because they're decreasing as they go further to the right. So that's the idea with standard form. So again, if we look at this first problem here, this number a here, this is ax squared plus bx. And then I don't have a c as I do on the top there, but I don't need one. The only thing that's essential here for any of these equations is that it has an x squared. So just something to keep in mind here. I don't have to have a b or I don't have to have a c. If one of them's missing, one of those terms is missing, I have to say that letter b or c would be 0. So in this case then, my c is actually 0. Now again, that doesn't really matter here, but when we get to some of the other ways to solve these quadratic equations, we'll see that that plays a bigger role for us. So essentially here, since I already have this in standard form because I have this polynomial x squared, something and other stuff, equaling 0, that's my standard form. So here, I just have to factor because this says solve by factoring. So I factor this left side here. And the way I do that is I simply pull out an x. And I'm left with x minus 9. And that gives me 0. Hopefully this is okay with you, this idea of factoring. If it's not, get a hold of me. All right, so anyways, that's our factoring there. Now we're going to use this idea called the 0 property. What that means is, if you notice when I factor here, there's a times here. So that means when I take this and I times it by this here, I get 0. So if you think about that idea, that simply means that either x is 0 or x minus 9 is 0. One of them has to be 0 if I'm going to times them together and get 0. Okay, so that's the idea here. So I'm just going to write what I just said mathematically. So x equals 0 or x minus 9 equals 0. And then essentially I just have to solve for x now. If you look at this first one though, this x equals 0, that's already solved for x. So I don't have to go any further with that one. Very simple problem that way. Now the next one here, this x minus 9 equals 0, I actually have to add 9 to both sides because I'm just solving for x. So then x equals 9. So there's my two answers for that first one. Now let's try the second one. Okay, now for the second one, this is 3x squared plus 2 equals 5x. Now if you notice, standard form again is ax squared plus bx plus c equals 0. So it has to be in that order and in that form, well, to be in that form. And remember, it has to equal 0. Okay, so this is a little mixed up. That's what I would say. This is just mixed up. So I would simply move the 5 over, the 5x. So I'm going to minus 5x to both sides. Now remember here, we also have to make sure the powers are descending. And remember, anything that's just a constant is degree 0. So you think of it like cx to the 0 power. Okay, so anyways, I'm just going to minus this 5x. And I'm going to get 3x squared minus 5x plus 2 equals 0. Now notice what I did there. I also put the 5x between the x squared and the 2 because that's its position in standard form. Okay, so now what we're going to do is we're just going to factor this. So I put my 0 in there. Whoops. Lost my 0. And then I'm just going to factor this. Now again, I'm just going to use trial and error for these factoring. To me, it just seems a lot easier to deal with here. So that one has to be 3x and one has to be 3. Because remember, I'm timesing those. And so that should give me the first term, which is 3x squared. And it does. Okay, so if that was a 4x, then I could put a 2x and a 2x there. And that would be 4x squared. So it just determines what this first coefficient is. They call that the leading coefficient. Anyways, back to the problem at hand. So now on the other end, I have a 2 here. So that tells me when I take these last two and times them together, that I'm going to have to get a positive 2. So that means the signs have to be the same, and 1 has to be 1, and 1 has to be 2. Okay, and they have to be the same sign. So now this is one way to look at it. Now if I take a look at this middle term here, this is a negative. So since these have to both be the same because that's positive there, and I times them together, that means I'm going to have to put a minus on both of those. Now take a look at this. When I times this 3x times negative 2, that's going to give me a negative 6x. And then when I times this negative 1 times positive x, I'm going to get a minus 1x. So that's going to give me a negative 7x, and that's going to be off from this. I'm supposed to get a negative 5x. So what that tells me is I put the 1 and 2 in the wrong place. So this should have been the 2, and this should have been the 1. Because now watch what happens here. That's going to give me my negative 2x, and that's going to give me my negative 3x. And when I add those together, I'm going to get that negative 5x. So that's going to work for us. So this is my factorization of 3x squared minus 5x plus 2. Now what I'm going to do is just kind of what I did for the first one. So my times is here now. So what that means is 3x minus 2 equals 0, or x minus 1 equals 0. And what we get from this one is I'm just going to add 2 and divide by 3. So my x is going to equal 2/3. And then for the other one, I'm just going to add 1 to both sides, so x equals 1. So this one is the two answers for the second one. Now let's take a look at this third one. This third one's a little different because this is one of our special factorings that we had from a long time ago. This is a difference. It's a subtraction. Okay, this is an x squared, and hopefully you realize that x squared is a perfect square. Also, 9 is a perfect square, and if you don't remember what a perfect square is when I times something by itself to get that number or expression. So if you think about it, 9 is a perfect square because 3 times 3 is 9. That's what I mean. So the same number times itself is going to give me that number, and for this one it's 9, which is a perfect square. And x squared is a perfect square too because x times x gives me x squared, and those are the same. Okay, so it has to be the same thing I'm timesing by itself. Okay, so now or timesing by it. Okay, anyways, so that tells me once I know that this is a difference, and difference means subtraction, of two squares, then I can use my special formula, which tells me, and I'm going to write this out for you because I want you to see something here. Okay, so this is an x and an x. That's going to give me x squared. And then remember, that's a perfect square too. And what makes a perfect square? 3 and 3. And then what I do next is plus minus. Now I'll kind of show you why I do that just so you understand, and if you've forgotten or haven't seen it in a million years, there you go. So the reason why I do a plus minus here, and I keep the same numbers there, is for this. When I do my middle terms, so I get the 3x there, and then I do the outers, that's going to give me a negative 3x. Notice what's going to happen there. Those are going to cancel out and give me 0 for those two middle terms. That's why I don't have a middle term here. So it just kind of shows you that. So that's why I have to go plus minus. So make sure you do that, plus minus, okay, when you see that difference of squares. Now again, I'm just going to go back to the 0 property again. So that means x plus 3 equals 0, or x minus 3 equals 0. And then when I solve these for x, this one's going to give me x equals negative 3. Okay, and this one here is going to give me x equals positive 3. So there's my two answers for this one. So now we just kind of seen 3 different types by solving by factoring.